This is just a quick learning video finding surface area of cylinders and cones. So we're going to focus first on the visual. So here you have a cylinder, and we talked in class about kind of unwrapping the paper that would go around a water bottle or a cylinder, and when you unwrap that, you have like the circumference here that unwraps to be the distance here. So this is the circumference of that cylinder, which is pi times the diameter, and then the height right here, which is be the height of this rectangle, and then the radius right here is just the radius there, and you have two circles and a rectangle. So just adding together the pieces to get the surface area of the circle, you have two circles, and so if you look below at that fancy little formula, it's just, in my opinion, easier just to think it through without memorizing a formula. You have pi r squared plus another pi r squared plus the area of this rectangle is just pi d, your length, times your height. So my personal preference is to not focus on the formula and just focus on the picture. So that's what I'm going to do. Whoops, a little early. I have a couple sample problems. Let me pause and find them. Okay, so this is just your basic surface area of a cylinder problem. We have two circles. Each circle has a radius of 3. I know that the distance around one circle is the circumference. That's pi times the diameter. Since the radius is 3, the diameter is 6. So 6 pi is the circumference. So when I think of my rectangle, this would be 6 pi. The height is 10. So the area in here is 60 pi. And this is 2 times 9 pi, because the area of the circle is pi r squared. So 2 times 9 pi plus 60 pi makes 18 pi plus 60 pi, and that's 78 pi. And the units are squared inches. That's how you do surface area of a cylinder. So the next thing is, what if the cylinder has a little bit of a hole bored through it? In other words, kind of like a pipe with thickness. So we really have more surface area, because we have the surface area of the outside, which is, and then we have the surface area of the inside. And then we have the surface area of the top and the bottom. So the outside is just a rectangle when you unfold this. So if we look at this picture, the little radius is a little hard to see. This little radius right there, that is 3, and the bigger radius, that is 5. The height is 10. So the outside, or the larger rectangle, has a height of 10. And then the circumference, if you look at that, is 10 pi, because when we look at the the larger circle versus the smaller circle, the diameter across is 10 units. So the circumference is 10 pi for the big circle. For the inside cylinder, it has a smaller circumference. So this is still 10, but the smaller circle, that has a diameter of 6 because the radius is 3. So this is 6 units. So the circumference of the smaller circle is 6 pi. So this is 100 pi, and this is 60 pi. Then we have the top and the bottom. So there's 2 pieces, and it's basically this little annulus over here. There's 2 of these, and basically we need this little shaded area. So that would be this. And when you do that, you basically just do the big circle. So the radius of the big circle. So you might think of it as pi capital R squared minus pi little r squared, big circle minus little circle. So 2 times 25 pi minus 9 pi. So that's 2 times 16 pi, which is 32 pi. Then we add these together, and we have 160 pi. So all told, we have 192 pi square units. The last problem is just finding surface area of a cone. For right now, we're going to be using a cone formula, and then we'll talk about deriving that formula after we complete this unit as sort of a exploration activity. So to find the area of a cone, you take the circle, which is pi r squared, and you add the area of the sector. And this, because the sector, when you roll it up, turns into the cone without the base. And L is the slant height here. That's what this is. And so really the expectation is that you just apply the formula. So pi r squared plus pi r L. So area of a cone is pi r squared plus pi r L, and R is 5, and we need L here, but this is a right triangle, so this is a 5, 12, 13, Pythagorean triplets. So we have pi times the radius of 5 times 13, that's 25 pi plus 65 pi, which is 90 pi. And this would be squared units. That's the cone area. That summarizes the day, between the video on polygon and surface area and of polygons and area of polygons, surface area of solids and surface area of cones.